Okay, here's the second part of the mixture of counting techniques for section 6.6. It's number 16 example. It says an ATM keypad has 10 keys. A PIN code is entered by pressing a sequence of 4 keys. So for part A, it says how many PIN codes are possible if no key is pressed twice in a code. Alright, so what we need to do down here, I'll put the counting technique down here. Alright, we've got, there's 10 keys, PIN codes, and represent a sequence of 4 keys. Alright, so we've got to press 4 different keys, and what we're going to look for are the choices for each of those numbers. Alright, because there's, 10 numbers all together, 0 through 9, and we have to press the first one, then the second one, then the third one, and the fourth one. But it says you cannot hit the same key twice, so you can't use the same digit over again. Okay, so let's count the number of choices for each one, and then since it's made up of 4, we have to multiply in between. Okay, so for the first choice, 0 through 9, there's 10 digits there. So the first digit, you pick any of those numbers you want to. But for your second digit, you can't choose the same number, so you've got one less choice, alright? You pick from the remaining 9 numbers that are left. Then there's 8 numbers, and there's 7 numbers left, right? Just like that. So here, we're totally using the multiplication rule. The number of choices for your first number of your PIN code times the number of choices for your second number of your PIN code, and so on. Alright, yeah, if you throw all that in your calculator, 5040. 5040. Alright, let me scroll down some. Alright, for part B, it says how many PIN codes are possible if a key may be pushed more than once in a code. Alright, we still have a 4-digit code. So in this first one, repetitions were not allowed, but here, for part B, it says, yeah, it's okay if you want to use 2 5s in there, for example, or if you want to use 5, 5, 5, 5, like that. How many PIN codes are possible if a key may be pressed more than once? Alright, so you got 10 choices for this. Doesn't matter, you got 10 choices for that, 10 choices for that, and 10 choices for that. Is that 10,000? Yep. Alright, very good. Because here, again, your PIN could be 1111 if you wanted it to be. Okay, or 7742, something like that. Repetition is allowed, so you got 10 choices for all 4 of those. Alright, let's scroll down to part C. Part C says, a bank changes the PIN codes to a sequence of 6 keys. Okay, let's jot those down. 3, 4, 5, there's 6. Alright, now it says, find the number of PIN codes possible if a key may be pressed more than once in a sequence. Alright, and then we'll discuss the increased security by going to a 6-key code. A key may be pressed more than once. Alright, so we've got 10 for all of these. 10 choices. Alright, there were 6 of those. I think that's 1 million. Alright, that's your answer there. And then it says, discuss the increased security by going to a 6-digit code. Yeah, if someone was trying to hack your PIN and try to get into your bank account, I guess, if the PIN was only 4 digits, there's only 10,000 possibilities. But if your PIN code is 6 digits, there's 1 million different possibilities. Alright, so it's going to be harder for them to hack with a larger code. That's why also sometimes they might want you to put letters in there or different characters. That just adds to the increased security. Alright, yeah, that's that example. That was a good example of the multiplication rule, where some are repeated and some aren't. Repetitions are allowed and some weren't. Alright, let's head down to this one. I think I have 2 more. Let's look at 18. 18 says, Student Congress, let me scroll up some, has 8 members who are seniors and 6 members who are juniors. Let's highlight that. 8 seniors and 6 juniors. Alright. At spring premiere for prospective students, one of the juniors greets prospective students, one works at the registration table, and a third gives a welcome to the campus greeting. One of the seniors introduces the dean of students, another introduces the academic VP, and a third discusses how to apply for financial aid. So how many ways can these assignments be made? All right, we got to choose a whole bunch of students here. All right, we've got 8 seniors and 6 juniors. All right, at the spring premiere, one of the juniors greets prospective students, one works at the registration table, and a third gives a welcome to the campus greeting. That's 3 distinct job duties. All 3 of those, and they are juniors, are going to do different things. All right, we've got 1, 2, and a third one, so we have to pick 3 juniors. Since their job duties are completely listed out, they're all doing different things, got to use a permutation. All right, permutation, how many juniors are there? 6, and we are choosing 3 of them. All right, those are the juniors. How many ways can these assignments be made? We also have these seniors. They're picking 3 different seniors. One of the seniors introduces the dean of students, another introduces the academic VP, and a third discusses about financial aid. So since we have to pick these 3 people and the other 3, we're multiplying. The 3 seniors' jobs are distinct. They tell us exactly what they're going to be doing, so you have to use a permutation. How many are there? 8. 8 seniors total. Again, we're picking 3 of those. All right, and how many ways can these assignments be made? These are the 3 juniors. These were the 3 seniors. Out of 8 total, and then 6 total. All right, you have to set it up this way. When you throw it in your calculator, it will give you that the answer is 40,320. All right. So for that one, even though the problem is kind of wordy, don't get bogged down in everything that's in there. What you want to do is look, how many total assignments are going to be made. First of all, we had to pick the 3 juniors and the 3 seniors. So we're multiplying here. It didn't say 1 or those 3 or those 3. So we got to make all 6 of these assignments. All right. So then we needed 3. There was a distinction between those 3 job duties for the juniors, and there were 6 of those. All right. 6, choose 3, permutation. Same with the seniors. Okay, let's look at one last one. That's it. All right, about 8 minutes. Got plenty of time for this last one. All right. For this one, it says the math club is planning a picnic. They will select 3 freshmen for the cleanup crew. Let's stop right there. 3 freshmen for the cleanup crew. They do not delineate between those 3 freshmen for the cleanup crew. It's just like a committee of these 3 people that are going to clean up. They'll figure out what little job duties they're going to do. But we're just picking 3 for a cleanup crew. This is from the freshmen. So there were, how many freshmen are down here? 6 freshman members. All right, so let's go ahead and write that down. Since there's no distinction between those 3 members for the cleanup crew, that is a combination. All right, 6 things, taken 3 at a time. This is for the freshmen. Okay, a menu committee composed of 1 sophomore and 1 junior. All right, I got to choose 1 sophomore. How many sophomores are there? There's 4 sophomores. So I've got 4 choices for that 1 sophomore that's on the menu committee. And 1 sophomore and 1 junior. A menu committee composed of 1 sophomore and 1 junior. Okay, that's 1 sophomore and 1 junior is going to be 8. All right, that's the menu committee. All right, this is cleanup. This is the menu committee, 1 sophomore, 1 junior. All right. And a program committee of 3 seniors, 1 of whom plans the entertainment, 1 presents the club awards, and 1 tells about the project for the semester. Right? There is a distinction between those 3 seniors And I've got 3 seniors. There's a total of 12. Alright, since they explained their different job duties, that's why we used a permutation here. There were 12 seniors total. We're picking 3 of those. Alright. And then it says the club has all these different members in it. In how many ways can the students be selected for the above assignments? All of those assignments have to be made. This was the cleanup crew, the 3 freshmen. This is the menu committee, these 2 people. One is a sophomore, one is a junior. And then the 3 seniors are on the program committee. And they have 3 distinct job duties. Alright, so you could key this in your calculator exactly. Do the 6 NCR 3 times 4 times 8 times 12 NPR 3 and enter. And it will tell you that it's going to be 844,800. Alright, so for each one of these problems, and especially on your test, just read through the problem. It'll be something similar to what you've done in the homework. All you need to do is read through the problem, make sure if you're either adding or multiplying, and then make sure if you're using a combination or a permutation. That's the big thing.